Hi guys, in this video let me explain the procedure for converting NDFA to DFA, that are NFA to DFA in detail. So now for the given NFA, Q sigma delta Q naught F. So you know already Q is nothing but finite set of states, sigma is a set of input symbols, and F is a subset of Q which is consists of set of final states, and Q naught is the initial state and delta is the transition function. So for this NFA, you can convert the equivalent DFA. So for every NFA, we can construct an equivalent DFA. So for differentiation purpose, so I make use of M dash. So here we make use of M to represent an NFA. So M dash is equal to Q dash sigma dash delta dash Q naught dash F dash, but with the same usual meaning of Q sigma delta Q naught F. Okay, only for the differentiation purpose we just use the dash. Okay, so here itself Q dash represents a set of states, but here we have to take set of states as power set of Q. So you know already only the difference between the definition of NFA and DFA is all are same, that is set of states, sigma input alphabet, Q naught, and the final state, everything should be same, only the difference is between the transition function. Whereas in case of DFA, your delta is a transition function from Q cross sigma to Q. Okay, so DFA Q cross sigma to Q, which means for in the current state, by reading an input symbol, there exists only one state, that is a unique state exists. By reading an input symbol, you can go to the current state to the next state. So for in case of NFA, the delta transition function is from Q cross sigma to 2 power Q. That is the difference between DFA and NFA. Whereas here we have so many possibilities. Here the next state is chosen at random in case of NFA, because for a state Q naught, by reading an input symbol, for example, so there exists a possibility to go to Q1. But in case of NFA, so in state Q naught, so if you read the input symbol A, you can have so many possibilities, like either you can go to Q1 or Q2 or Q3, something like this. So we are having so many possibilities. So that is the difference between DFA and NFA. So that is why we are having the transition function here from Q cross sigma to 2 power Q. So here our Q dash is nothing but power set of Q. Here you have to take Q dash as 2 power Q. Okay. So in DFA we have to take, and there is no change in the symbol sigma. Okay, and also the initial state Q naught is also the same one. So in case of differentiation, I have to use Q naught dash. That's all. Final state also there is no difference. Okay. So here itself F dash is nothing but subset of Q, and delta is the transition function for the power set 2 power Q of Q. So we can construct the delta for the DFA. And finally we can draw a transition diagram and identify which of them final state, and also we have to delete the states which can never be reached from the initial state. Okay, so after that we can obtain the simplified DFA that is equivalent to the given NFA. This is what the procedure we are going to follow. For that, let me take a simple example for your clear understanding. Before that, you should know this one. So if L is the, let L be a set accepted by an NFA, then there exists an DFA that also accept L. That is, for every NFA we can construct an equivalent DFA. This is an important thing. Okay. So for every NFA, NDFA or NFA. So for every NFA we can construct an equivalent DFA. So let me now move on to an example. So let M be a machine. So this is your Q. That is set of states Q naught, Q1. And this is your sigma. Sigma is nothing but the two input symbols 0 and 1. Delta, the transfer function is defined here like this using the transfer function. Here Q naught is here, this is the initial state. This is Q naught is the initial. This is nothing but your final state. Okay. So for NFA, so we can have all Q sigma delta Q naught and F. So now we are going to convert this NFA to an equivalent DFA. So now what we are going to do is, and let me explain in short, after that I will explain in detail. So here Q is nothing but Q naught Q1. So power set of Q, 2 power Q, we have to find out what we are going to do. So here we have only 2 states. So 2 power 2 means we have 4 subsets we have. That is pi Q naught Q1, Q naught Q1. These are all the 4 different combinations. isn't it? So that is your Q dash, and there is no change. Listen here. So here pi Q0 Q1. So for in case of DFA, I have to write this as within the bracket like this. This is also a state. Q0 is a state. Q1 is a state in DFA. Q0 Q1. This is a single state. Q0 Q1 is a single state. That is in DFA. Okay. That's all. And there is no change in sigma. That is the input symbol 0 1. And here your initial state is Q0. So Q0 dash is nothing but your initial state, because in case of NFA given here, that is Q0 is your initial state. So we make use of this transition function. So we can convert the given NFA to DFA like this. That is what I am going to explain in detail to you now by taking a clear page. Now, so after that we have Q dash, sigma dash, delta dash, Q0 dash, F dash. So this is all what we have now, right? So now let me explain this in detail to you now. So what is given? So what is given? So given your M, that is set of states. What is your Q given in case of NFA is given? Given NFA, your Q is nothing but set of states. What are the set of states? Q0, Q1. Okay. And sigma. What are the two input symbols we have? 0 and 1. Okay. And next, Q0 here is the initial state, isn't it? And next, which is the final state? It is given that Q1 is the final state. Q1 is the final state. So these are all given along with the transfer function. So transfer function is given in terms of function. So I have to take it in terms of table like this. So here you have states and there we have input. So we have two inputs 0 1. We have two states. What are the two states? Q0 Q1. So in Q0 if you read 0, what is given? Delta of Q0 comma 0 is Q0 Q1. It is given, right? By reading in Q0, if you read 1, then you are in state Q1. Next, in Q1 if you read 0, what? There exists no state. In state Q1 if you read 1, then you have Q0 Q1. You are having two possibilities. Okay. These are all given in a problem. So for this, let me construct a NFA. So what is the initial state? So Q0 is your initial state. So arrow labeled start indicate that is initial state. So now in Q0 if you read 0, you either you are at Q0 or you can go to Q1, and Q1 is the final state, so you have to represent it in terms of two circles. Next, by reading 1 in state Q0, you move on to Q1. So reading 1, you move on to Q1. Next, in Q1 if you read 0 means there is no state, that is empty state. Next, in Q1 if you read an input symbol 1, then you are go to Q0 by reading 1. Okay, by reading 1 you have to go to Q0, or you can again at the same state Q1, so that you have to draw a loop with the label 1. Now this is the given NFA. This is the given NFA. So for this NFA, you are going to construct an equivalent DFA. Okay, so for that what we are going to do, as I told you already, so your Q dash. What is your Q dash? Q dash is nothing but 2 power Q. So here we have two states. So for two states we have 2 square is nothing but 4. So we have 4 states. So first one is always an empty set pi. Okay, first one is always an empty set pi. So this is an DFA. That's why we make use of the square bracket to differentiate that. Okay, the states between NFA and DFA. So I make use of the square bracket. So the states in DFA can be represented within the square bracket like this. Okay, now this is the first state, empty set. The second one, so for the states Q0 Q1, so first I have to write Q0 and Q1. So this is for DFA. Now we have to work out this for DFA. So now Q0 Q1. Next one, the combination of Q0 Q1. Listen here. Here Q0 Q1 is a single state, not different states. Okay. Q0 Q1 is a single state like Q0 and Q1. This is also one of the single state. Next, So this is q dash. Next sigma dash. So the states in that is sigma dash is nothing but input symbol. So there is no change in the input symbol. So you have to take it as it is in case of NFA. So your sigma is 0 1. So sigma dash is also 0 1. Next, what is your next one? Initial state. What is the initial state? Here you have q naught is your initial state. Q naught is the initial state. So here itself q naught is your initial state, but in DFA we have to represent all state within this square bracket. So this is the initial state. Okay, initial state. Next, which is the final state? Q1 is the final state here. Which is the final state here? Q1 is the final state. Look at these states. The state containing Q1, we have to take it as a final state. This is a state consists of Q1 and this is a state consists of Q1. So you have to take these two as a final states. So we have two final states. One is Q1, another one is Q0, Q1. So this is a final states. That's all. Next we have to construct the transition function table. So here we have states as row, as a column you have input. So inputs we have 0 and 1, whereas in states we have first one empty state pi, the second one Q0, next one Q1, next one Q0, Q1. That's all. For the empty state, so for the empty state we don't have, for that we make use of this transition table. For the empty state we doesn't have any other state exist by reading 0 or 1. So by reading 0 or 1, so the empty state is state itself. So pi and pi. In Q0, if you read the input symbol 0, what happens in Q0 if you read the input symbol 0? So look at the NFA. So in this NFA, in Q0, if you read input symbol, you go to Q0, Q1. So Q0, Q1. So this here, listen here, this is in Q0, in NFA, in Q0 if you read 0, we are having two possible states Q0, Q1. But whereas in case of DFA, in Q0 if you read the input symbol 0, you are having a unique state Q0, Q1. This is not different two states, okay. Within the square bracket Q0, Q1 is represent a single state, okay. Next, in Q0 while reading 1, you have Q1. That is Q1. Next in Q1, if you read 0, in Q1 if you read 0, what happens? If you read 0, so you have only empty state, no state exists. Next in Q1, if you read 1, so you are having two states. So two possibilities, either you go to Q0 or you are again at the same state Q1. But here, you have to write Q0, Q1, which means you are at the state Q0, Q1. Q0, Q1 here is a single state. Next, Q0, Q1. In Q0, Q1, so how can we write down this Q0, Q1 status? You have to take the union of these two. That is, take the union of these two by reading an input symbol Q0, Q1 pi. So, you have Q0, Q1. Next, Q0, Q1 by reading 1. Q0, Q1 union Q1. That is Q0, Q1. That's all. So, this is the transition function. Okay, simple. Within a page you can complete and give an equivalent DFA. Okay, that's all. Now, so the next page I have given the complete diagram. So this is an NFA, given NFA. For that we have to construct an equivalent DFA. So this is what the equivalent DFA. So for that we are having the transition functions. In Q0, if you read 1, you go to Q1 or Q0, Q1 like this. So just draw the diagram, and finally what you are going to do is you have to check whether there exists, that means whether all states are reachable from the initial state or not. Look at Q0, Q1. So this is reachable from the initial states. So we can add this. So look at this Q0, Q1 state. So this is also reachable from the initial state. So no need to leave it. So take it. Next, let us take the empty state pi. It is also reachable from the initial state through Q1. Okay. So there exists a path. So which means we can take this too. So none of the states can be deleted. So we can take all the states. So along with these input symbol. So this is what the DFA equivalent to the given NFA. Okay. So that's all. So I think hope you got a clear idea about how to convert a given NFA to DFA. Next, construct the DFA equivalent to given NFA. Let M is equal to Q sigma delta Q naught F, where Q is equal to set of states and sigma is the input alphabet and Q naught is the initial state and Q2 is the final state. The transfer function delta is defined by, here the transfer function is given, and also the NFA also given in terms of diagram here. So what you are going to do, you have to construct an equivalent DFA. So here, as I told you already, you are having three set of states. So this transfer function table is must. So or from the diagram itself we can construct this table. That's all. Now what we are going to do, first we have to construct Q dash. Q dash is nothing but sigma dash means there is no change in the input alphabet. So you are having only two alphabets, A and B. So two symbols, that is A, B. So sigma and sigma dash is nothing but A, B. So Q dash is nothing but 2 power Q. 2 power Q means you are 3 states. So 3 states. So 2 power 3. 2 power 3 means totally we have to construct 8. So first one is empty set. Q0, Q1, Q2, you take it separately and combine 2, that is in terms of Q0, Q1, Q0, Q2 and Q1, Q2. So next you have to pair it in terms of 3, that is Q0, Q1, Q2. Listen here, Q0, Q1 here is a single state and Q0, Q2 is a single state and Q0, Q2, sorry Q1, this is a single state and this is also one of the single state. Okay, if you write like this Q0, Q1, Q2, which means you are having three possibilities. Okay, Q0, either you are at Q0, Q1 and Q2. But if you write within the square bracket like this means this represents a single state like Q0, Q1, Q2 you can take, right? So keep it in mind. Next, which is the initial state? As I told already, Q0 is the initial state, right? Q0 is the initial state means here itself Q0 is the initial state. And which will be the final state? Look at the diagram. The final state is Q2. So in this subsets, that is in Q dash, you have to take the states which consist of Q2. What are the state consists of Q2? This one consists of Q2. So take it. Next one, this one consists of Q2. Take it. Next, this one consists of Q2. Take it. And this one consists of Q2. You take it. And now let me find. Now you know what is sigma Q dash. We can write an initial state, final state. Now we can write down the transfer function. So for that, to write down the transfer function, what we do? Make use of this NFA transfer function. So that is very simple. Look at here. So this is for DFA. Okay, the transfer function for DFA. So side by side, I am just write down the NFA transfer function table for your clear understanding, right? So here states and input. So what are the different possibilities we have? Q0, Q1 and Q2. So input symbols here we have A and B are the two input symbols. So now by reading Q0 A, we have two possibilities. Either you can at Q0 or Q1. And for B, nothing, empty state. Q1A, empty set. Q1B, Q2 alone. Next Q2A, empty set. And Q2B, Q2 alone. That's all. This is what given. Okay. This is what given. From this, we can construct an equivalent DFA. Now, for that, write down A and B. These are the two input symbols. So, for that, we have totally 8 states. Okay. So, for these 8 states, first one empty state. By reading an input symbol in empty state, whether it is A or B or again at the same state. Next, for Q0, so for Q0 you have Q0 Q1 pi. So Q0 Q1 pi. So here Q0 Q1 here is a single state, but here you have two possibilities. Okay. So Q0 Q1 pi. Next Q1, so you have pi and Q2, pi Q2. Next Q2 you have pi and Q2, pi and Q2. So here you have to write within the square bracket, which means that represents a single state. Okay. Now, let me write down Q0 Q1. Q0 Q1 can be written as by combining or taking the union between these two. That is Q0 Q1 pi. That is Q0 Q1 alone. Next, for reading an input symbol B, pi with Q2, so Q2 alone. Next, Q0 Q2. Q0 with Q2. So you have to take the union for these two. That is Q0 Q1 pi. That is Q0 Q1. If you take in union. Next, for reading an input symbol B. Pi with Q2 union gives you Q2 alone. Next Q1, Q2. Q1, Q2 means pi with pi. Taking in union gives you an empty set. Next Q2 union Q2, Q2 alone. Next Q0, Q1, Q2, which means you can take the union of Q0, Q1, Q2 for reading an input symbol A, that is Q0, Q1, pi and pi. So you have Q0, Q1 alone. Next pi union Q2, so you have Q2 alone. So this is what the states we can obtain for you for reading an input symbol A and B. So in case of DFA, so I have constructed diagram for this one. Okay, so here the initial state is Q0. So here the initial state is Q0, and also we can have set of states, that is these are all the final states consisting of Q2. So we can double circle that and draw a label from A, B by reading an input symbol. We just draw like this. So what we are going to do is whether each state can be reachable from the initial state or not. That is what we are going to verify. If it is so, you can leave it, take the DFA as it is, or otherwise you can remove the states and you can simplify the DFA for the given NFA. So now look at the state Q0, Q1. The state Q0, Q1 is reachable from the initial state. So you can take it. Next Q1. So here in Q1 there are two paths exist, but these two paths are outgoing paths. Look at here, these two paths are outgoing paths, which means there is no incoming path, which means this state is not reachable from the initial state, so you delete it. Next Q2. Look at Q2. This state is also reachable from the initial state, okay, through this path, so you can take it. Next Q0, Q2. Look at this state. So there exists two paths, but two paths are outgoing path. So which means there exists no path between the initial state to final this state. So you can delete it. Next, look at this state. This state also having two paths. These two paths are outgoing path, which means this state is not reachable from the initial state, which means there exists no path between the initial state to final state, so you delete it. Next, look at this state. So this state also having two paths. These two paths are outgoing path. Outgoing path means what? There exists no path. There is no incoming path labeled like this. Okay. So which means this state is not reachable from the initial state. So you delete this state. So now we have only these states alone. This one and pi. This state also, look at this state. Pi can be, so look at here, the state pi. So pi, there exists a path. Here, there exists a path of pi from the initial state. So this is reachable. So you can take it. Okay, through a label B. So you can leave it. That's all. So for pi, by reading an input symbol A, B, you can draw a self loop. A, B. Okay, that's all. Now, after deleting all these, so the states Q0, Q2, Q1, Q2, Q1, Q0, Q1, Q2, which cannot be reachable from the initial state, so we can delete these states. So we can obtain the equivalent DFA corresponding to the given NFA as follows. So by reading A, B, you can have a loop like this. Okay. Now this is what the equivalent DFA for the given NFA. That's all. So hope you got a clear idea about how to convert a given NFA to an equivalent DFA. Hope you got a clear understanding about how to convert an NFA to an equivalent DFA. So these two examples for your reference. Okay, do it at yourself. Thank you.